Education Manager at Benjamin Franklin House. Welcome to this week's virtual class, which is all about Ben Franklin's fuel-efficient stove. And we're also going to be thinking a bit about how scientists today have been following in his footsteps and still try to save or conserve fuel. If you're watching this live, we're really looking forward to you getting involved with your questions or answers or comments. And there's two ways that you can do this if you're watching live. The first way is to use your raise hand button. So to do that, you need to either tap your screen or click your mouse, and then you should get some icons or pictures coming up along the bottom. And one of those is a picture of a hand. And if you tap that, then my friend Caitlin, who also works at Benjamin Franklin House, will be able to unmute your microphone, and then you can ask your question over the audio, and I'll do my best to answer it. The second way you can ask your question is by using your Q&A button. So once again, you tap the screen or click your mouse, and those icons appear. And one of them is a picture of two speech bubbles. And if you click that, you can type your question and Caitlin will read it out. And again, I'll do my best to answer. We're also recording today's session. So if you're actually watching this on YouTube, then you can write your question in the comments and we'll get back to you as soon as you can. And you can always get in touch with questions or feedback. And we'd also love to see any photos you'd like to share of the demonstrations you recreate at home. You can send those to education@benjaminfranklinhouse.org. So, the starting point for today's lesson is Ben Franklin's fuel-efficient stove. Now, on the screen, you should be able to see an illustration of the stove on the left, and this was done by Kramina Dimitrova, who's our illustrator in residence at Benjamin Franklin House. And on the right of the screen, we've got some writing, and that is something that Ben Franklin said in his autobiography, which was a book he wrote, which was the story of his life. And in it, he explains why he wanted to invent this stove. So he wrote, "I invented an open stove for the better warming of rooms and at the same time saving fuel." So the idea behind the stove was to try to make sure that the room stayed warmer for longer, and also that you didn't use so much fuel when you were burning a fire. Now, like many of his other inventions, Ben came up with the idea for this one because he was trying to solve a problem that he came across in everyday life. He was very practical, and he was also very good with his hands. He had to be very good with his hands so that he could operate the printing press, which was what he did in his first job as a printer, both in Boston and Philadelphia. So those skills, as well as his curiosity, made Ben a really good scientist and inventor. Before we talk more about his process of invention, let me tell you a bit more about Benjamin Franklin House and also why Ben Franklin came to London. So on your screen now, you should see a few different photos. The one on the left is a picture of Ben Franklin House today, so also known as 36 Craven Street, which is its address in London. It's right in the centre of town by Trafalgar Square. And the other photos are pictures of some of the rooms from inside Benjamin Franklin House. And we're very lucky. Benjamin Franklin House is not only the only house that Franklin lived in that's still standing, but it also has a lot of the original features that he would have known at the time. So, for example, the floorboards he would have walked on. But why was Ben Franklin in London? So he came in 1757 when he was 51 years old. And although he had lots of scientist friends in London and he did continue making inventions, his main reason for being in London was as a politician. So at the time, there were some disagreements between England and America, and he was trying to settle those disagreements to find a solution. Now, if we look back to the images of the inside Benjamin Franklin House, I mentioned the floorboards, but there are some other features of the room, some original features that we can see in all three photos. Now, there are a few answers to this, but there's one I'm looking for in particular. I wonder if anyone could either raise their hand or type in the Q&A and let us know what's one of the features in which you can see in all three of those rooms.
I have a raised hand from Emily.
Fantastic. Hello, Emily.
The fireplace.
Exactly, well done, thank you so much. So in a lot of the rooms, the historic rooms in the house, we have these beautiful fireplaces that are made out of marble. And there are actually 5 floors in the house. You can see 4 of them in the picture, and maybe you can just about see the 5th one, which is the basement under the street level. So 5 floors. And at Benjamin Franklin's time, there would have been at least 2 fireplaces on each floor. So doing some quick maths, we can see that there would have been 10 fireplaces at least in the house at the time. I wonder if anyone might be able to have a guess at why there were quite so many fireplaces in Benjamin Franklin House. Why did they need so many fireplaces?
We have a raised hand from Irene.
Hi, Irene.
I think they need so many fireplaces because back then it would be very cold, and if they wanted to keep warm, they'd have to have quite a few fireplaces. The whole house would be very, very warm.
Fantastic. Thank you so much. It was a great answer. Exactly. So Benjamin Franklin was in London during the 18th century. So in England, we also call that the Georgian period, because at the time there were several kings called George who were in charge of the country, who were ruling. So we call it the Georgian period. And at that time, the way that houses were built, they weren't as well insulated as our houses today. So that meant that it was easier for the cold air to come in, either through the windows or under gaps under the doors. And so it could get quite cold, and they didn't have any electric heaters or central heating like a lot of houses have today. So the fireplaces were really important, which is why they had quite so many of them. Now, to have a fire, you need to have a few things, one of them being fuel. Does anyone want to have a guess at what fuel they probably would have used at Craven Street? What do you think they would have burnt in the fires to keep the rooms warm?
We have a raised hand from Irene again.
Hi, Irene.
Hi, I think they might have had to use coal.
Yeah, you're spot on, exactly. So in London, we know at Craven Street they would have used mainly coal, exactly. And we also think at Craven Street, Ben Franklin did have one of his stoves in one of his rooms that he rented. And we think this because there are some traces in the stonework in the fireplace. But actually, he didn't invent his fuel-efficient stove when he was in London. He invented it a few years earlier back in Philadelphia, in America. And there they would probably have used more wood rather than coal. So let's find out more about how he came to invent it and how it worked. Okay. So Ben Franklin invented the stove, and we call it fuel efficient. Efficient means when you can do something with as little effort as possible. So in this case, using as little fuel as possible. So he invented his fuel efficient stove, or the Franklin stove as it became known after him, in 1742, which is when he would have been 36 years old. And at that time, he was still working as a printer, but he was getting more and more interested in science and inventions. He'd come up with some inventions throughout his whole life. In fact, next week, we're going to be looking at some swim fins that he came up with when he was really just a young boy. But when he would go on to retire a few years later in 1748, that was when he'd have a lot more time to really do lots of science. But he was still doing some at this point. Now, most of the pictures that we see of Benjamin Franklin, the images that are familiar to us, show him when he's quite a bit older, when he's an older man, when he was doing his politics between England and America, and later with France as well. But on the screen, we can see a portrait that was done more around this time, so when he was a bit younger. So on the left, we have a painting of Franklin, and that is painted by Robert Feek, and you can now find it today at the Harvard University Portrait Collection in Boston. And the other picture on the screen, so this is Franklin's diagram of the stove and showing the different parts, and he published this in a pamphlet, which he was trying to use to advertise the stove and explain how it worked to get more people to use it. And today you can find this in one of the libraries at Yale University, which is in New Haven, also in America. So let's explain how it worked. Now, at the back of the iron stove, there was something called a hollow baffle. Now, I wonder if you've heard that word hollow before. Can anyone explain what it means if something is hollow?
So we have another raised hand from Emily.
Does it mean that it's empty on the inside?
That's really well explained. Thank you so much, Emily. Exactly. So if something's hollow, you're quite right, it's empty on the inside. So it would have been like a thin iron box, and at the bottom it was open. And then at the top of the box on the two sides, there were two holes. And what would happen is the air would go in the bottom, and then that air would get heated by the flames in the fire. Now, putting our scientist hats on, does anyone know what happens to air when it gets heated? Where does it tend to go? To help you, you might want to think about what you might have seen air do above a radiator, or when it comes out of a kettle, or above a hot bath. Does anyone think they could describe what happens to air when it gets heated?
So we have a raised hand here.
Hello?
It rises.
Thank you. Fantastic. Brilliant. Exactly. Heat rises. And we're going to come back to this idea in a couple of weeks, actually, when we do our lesson on the Gulf Stream. So we're going to come back to that. But you're quite right. Heat rises. So the heat would have to rise, and then it would have to go back down and up again, because also underneath the stove, there would be a U-shaped hole in the floor. So because the stove was making the hot air take a longer journey before it went up the chimney, that meant that it was staying in the stove and heating the room for longer. So we're getting more heat out of less fuel. Also, the iron sides of the stove were able to absorb the heat. So even when the fire went out, it could still keep the room a little bit warm. So there are lots of ways that it was really helpful, and it also stopped quite so much smoke getting into the room. So let's find out what happened after it was invented. The Franklin stove, as it became known, did become very popular. So Benjamin Franklin, when he invented it, was living in the city of Philadelphia, which is in what we now know as the state of Pennsylvania. But at the time, they weren't called states, they were called colonies. So in his autobiography, again, that story about his life, Ben Franklin makes this comment about what happened with his fireplaces and how people started using them. So he said, the use of these fireplaces in many houses, both in this and the neighboring colonies, so in Pennsylvania and the areas around it, has been and is a great saving of wood to its inhabitants. So its inhabitants, the people who lived there, so the people that were living in those places were saving lots of the wood that they would have used if they hadn't had the Franklin stove. So he's explaining how not only was it very popular, but it was having this really useful effect. Now, there were some other things that Ben Franklin tried to encourage people not to waste. He was very interested in making sure we didn't waste things. And one of those things was what he would have had to use at nighttime if he was going to do any reading or writing or working at nighttime to see by. Who thinks they could guess what he had to use if he wanted to see when it was nighttime, when it was dark? Because they wouldn't have had electric lights yet.
So we have a raised hand from Cato.
Hello.
We have somebody else who said a candle.
Exactly. Well done. That's exactly it. He would have had to use candles. And actually, Ben Franklin's dad made candles. That was his job. He was what we call a tallow chandler. So he made candles and soap as well. And Ben Franklin really hated to see people waste these. They could be quite expensive, especially good quality ones. So he advised that people should, instead of staying up late and working with candlelight, they should get up early and make sure they use the daylight instead. And he came up with this very famous phrase that was intended to encourage people to do that, which you might have heard before. So this is at the bottom of the screen, and it was early to bed and early to rise makes a man healthy, wealthy, and wise. So making sure you go to bed early and get up early as well, so you can use all the daylight there is. Okay, so what with Ben Franklin wanting to save fuel and also candles as well, we could maybe describe him as a kind of early environmentalist who cared about saving these resources that we have. Today, that's one of the things that scientists are really trying to work on. They're trying to make sure that all of our buildings can have heat and also light through electricity these days, and that can be made in a sustainable way, in a way that's good for our planet. So let's find out a bit more about that. So I wonder if you've seen these before. All across the world, scientists are working towards something called the Sustainable Development Goals, or we call them SDGs for short. And you can see there are 17 of them. You've got the different pictures that explain what they are. And these were set by the United Nations, so the UN, in 2016. And they were set because we want to try and protect both people and the planet and make sure we have a better world for everyone. So many countries across the world are aiming to achieve these Sustainable Development Goals by 2030, so in 10 years from now. And two of them really relate to what we've been talking about today. So if we look at Sustainable Development Goal, or SDG 7, so this is the yellow one on the left, it says to provide affordable and clean energy. So we'll come back to what it means by clean energy. And then the one below that, number 13, is climate action as well. So make sure that we're looking after our planet. So let's think about how scientists are creating energy for us and trying to make sure that that is affordable, clean, and also looking after our planet. Now, traditionally, most energy was not created in a very clean way. Power plants would not, traditionally they used to mostly use fossil fuels. And at the bottom of the screen, we've got three images of the different fossil fuels. You might have heard this word before. I wonder if anyone can tell us what those images are of, what the different fossil fuels are.
Have a raised hand from Irene again.
Hi, Irene.
I so the first one is coal, the second one is oil, and the third one is gas, I think.
Fantastic, you're spot on. Thank you so much. Exactly. So those are the fossil fuels. And these fuels are natural resources. They get formed over thousands and thousands of years. But the problem is, or there's a couple of problems. The first problem is that they're running out, and we can't replace them, which is why we call them non-renewable. They can't get replaced. And another problem we have with them is that when we burn fossil fuels, it's not very good for our environment, because burning them creates something called greenhouse gases, and that's one of the main reasons that we're getting global warming, and that there's negative effects of climate change. So lots of scientists now are working on ways to use more renewable energy. So I wonder if anyone's heard about that, and if they know some different ways we can get energy that is better for our planet, that's using resources that aren't going to get used up. Does anyone have any ideas?
We have a raised hand from Kato. Oh, the hand went down. We have somebody else that's raised their hand.
Fantastic, you're quite right. That is one of the ways. In fact, that's certainly in the UK and the US, the most popular way. What was the second one?
Sun.
The sun, exactly, well done. There's two more that I was looking for. Wonder if anyone knows those ones. So we've had the wind, the sun. Are there any other things we can use?
You don't have to raise your hand on this one, but another one, so that you know, is hydro.
Hydro.
Oh, no, that's cheating, because I'm telling you the answer, but I'm just.
Fantastic. So I think I had power, so using water. And then there's one last one. I don't know if there's anything in the comments or Q&A.
Yes, so we've got water power, waves, solar power.
Fantastic. And the last one I was looking for was geothermal. So I'm going to come on and explain different renewable resources work. So thank you so much for contributing. We got most of them. So quite right, you said wind power. So the picture on the top left, that's a wind turbine. And when those blades you can see get moved by the wind, then the turbine can change that kinetic energy, which means movement energy, into electricity. Then the next photo is of solar panels. So these take in all the light and heat energy from the sun and change that into electricity. Now the photo on the bottom on the left, that's hydropower. So that's using water. So you can either do that from water moving down through a dam, or also using the tides in the sea. So when the tides go back and forth. So that's also taking kinetic energy and changing it into electricity. And then the third one, geothermal, this is when you have volcanic activity under the earth, and that heats up water in the earth, and then that comes out at the surface as steam, and that can get turned into electricity. So we call these resources renewable because they're not going to run out. They're much better for our environment, and that's what we're trying to move towards now. And I mentioned briefly that wind power, that was the first one that was mentioned, and in both the UK and the US, it is the most popular of these renewable energy sources. In fact, in the UK, now we've got to a point where 20% of our electricity is created by wind farms. So let's look a bit more closely at how wind turbines work. We've got a few pictures on the screen now. So the one on the top left, that's showing you the inside of the wind turbine. So what happens is the wind turns the blades, and then this will turn the axis, so that's the red part that you can see, and then that turns the shaft, so the dark blue part, which then moves the generator, which is the turquoise box, and the generator is what converts the kinetic energy from those turning blades into electricity. And then if we move to look at the big picture on the right of the screen, this is kind of showing where it goes next. So from the generator, it has to go to something called a transformer, and that will make sure that the electricity is the right voltage for the area it's going to get sent to. And then it gets sent via pylons and cables. It gets sent into our homes. So that's how it goes from the turbine to power our homes. Now, there's one more image on the screen, and it's also labeled on the diagram of the wind turbine. And this is an instrument that is used to measure wind speed. So scientists will use this to go and find where's a good place to start wind farms, because it gets a lot of wind. I wonder if anyone's seen that before or has an idea of what it's called.
We have a raised hand from Emily.
Hi, Emily.
Say that word.
Anemometer.
Very good. Anemometer. I've been having trouble saying it as well. Anemometer. So this is actually what we're going to be having a go at making as part of the demonstration part of our lesson today. So I'm going to stop sharing my presentation, and I'm going to show you how we can make one at home. So here's one that I did earlier. So this is what it's going to look like. And we can use this to measure wind speed, and it's what scientists use to find places that they should start wind farms. So let me start by telling you what you're going to need. So you're going to need 5 paper cups, 2 straws, 1 sharp pencil with a rubber or an eraser on the end, and 1 push pin. Doesn't necessarily have to have a ladybird on it, just a push pin. Oh, and also to help you, a hole punch. So the first thing you need to do is we're going to make some holes in the cups. Now, I actually did this earlier just to save a bit of time, but I'll take you through the different holes you need to make. So on 1 cup, you're going to want to make 4 holes. So you're going to make them in a kind of cross shape. So 4 around the top of the cup. So these 4 holes here. Now you can use your hole punch to do this. If you don't have a hole punch, you can probably use your sharp pencil to make the holes, but you have to just be really careful when you do that. So you don't want anyone to poke themselves with the pencil. And if you do use a hole punch, you might find that the holes are a bit small, so you can then always poke the pencil through to make them a bit bigger. So you've got your 1 cup with the 4 holes, and then on all the other 4 cups, you're going to want to make just two holes quite close together near the top or the rim of the cup. So you want to do that on the other 4 cups. So you can either have a go at doing this as I go along, or have a go at doing it at the end. We're gonna put this whole lesson up on our website tomorrow, but later today by about 5 p.m. I'm also going to make sure there's a little video of just the method of how to make the anemometer, if you want to rewatch that to see how to do it again. So remember, we've got our cup with the 4 holes, and then 4 cups with just 2 holes near the top, close together. The next thing we need to do is take the cup with the 4 holes and take our sharp pencil, and we're going to poke a hole right in the middle of the base of the cup. Okay, so we've made our hole. And then I'm going to take my 2 straws and I'm going to thread them through the holes in the top of the cup, so it's making a cross. So it should, yours might even be a more perfect cross than my one. Mine's a little bit lopsided. So you've got the 2 straws going through, and then we're going to want to attach each of the cups to the ends of the straws, and you want to have all the cups facing the same way. So you're just threading the straw through like this.
We had a question of what else you could use other than straws to do the cross.
Pardon?
We've had a question about what else you could use instead of straws to make the cross.
I think it should work as well if you use pencils, possibly. You could use pencils instead of the straws. Okay, so I'm nearly there. I've nearly attached all of my cups, and I'm making sure they're all facing the same way. Got attached. And then I'm going to take my pencil and I'm going to put it through the hole I made, and I'm going to make sure that the rubber or the eraser is going in first. So I'm going to poke that through. And then I can use my push pin to attach the pencil or the rubber to the straws. So I'll push the pin through the straws, and then it will go into the eraser or the rubber, and then that should fix it all together. Okay, and then you should have your anemometer. Now, the way that you'll then measure the wind speed is you need to go outside on, it would need to be quite a windy day to do it outside, and you want to measure how many times it goes round in 1 minute and keep count of that. So I've got different coloured cups, so I might maybe keep an eye on the yellow one and count how many times it goes round in 1 minute. To time the minute, you might want to use a watch, or you could use a timer on a phone or a tablet. If it's not a very windy day, and it's not a very windy day here, you can also experiment with it inside. So you might want to use a hairdryer or a fan, and if you turn that on, you'll have it spinning round, and you can measure how fast the air coming out of the fan is going, or the hairdryer. So once I've got it spinning, I would then start my timer and count how many times the cup I'm keeping an eye on. If you haven't got different coloured cups, you might want to make a mark on one of them so it's easier to keep track of, and then record how many times it goes round. So there we have it, how to make your very own anemometer. Did anyone have any questions before we end the lesson?
No questions so far.
Okay, well, I really hope you've enjoyed learning about Ben's fuel efficient stove, and also how scientists are following in his footsteps today to try and make sure we use clean energy, and that we're looking after our planet and working towards those sustainable development goals. Remember, if you do think of any questions at any point, you can always get in touch by sending me an email to education@benjaminfranklinhouse.org. And we hope we might see you at the same time next week. In the meantime, if you'd like to use any more of our resources, or or to make a donation to support the work we do at Ben Franklin House, you can visit our website at www.benjaminfranklinhouse.org. But goodbye for now, and hope to see you soon.